Hi, so now we're going to practice doing some stoichiometry. And stoichiometry is much like the mass and atoms and molecules and moles problems we did previously, but these involved always have something to do with balanced equations. And so I'm just going to launch right into the example for this one. It reads, how many grams of ammonia are produced from 5,600 grams of nitrogen in the following reaction? This is a very popular reaction. One that changed the world, really. It's called the Haber Cycle, and it's the combination of hydrogen and nitrogen that makes ammonia. And it was very difficult to do. It only happens at high pressure and only with a catalyst. The Germans came up with this and essentially fed the world because this material is used to make fertilizer. So how would we do this problem? Well, let's look at it. We're giving grams of, let me change this here to color. We're giving grams of nitrogen. So we have grams of nitrogen. And out of that, we have to convert this to grams of ammonia. But the way we have to do that is through this balanced chemical reaction. And these stoichiometric coefficients right here, there's an implied 1 there, or 3 to 1 to 2. Are something that we need, but they're not in ratios of grams, they're in ratios of moles or of count numbers, any count, but certainly not grams. And so the way that this works is you have to start with the grams of nitrogen and you have to turn that into the moles of nitrogen, and then you have to turn that into the moles of ammonia. And you have to turn that into grams of ammonia. So here's how this works. Here's what you need to do each one. To get from grams to moles of, let's change this to blue here. To do this, you need, I'm going to draw the periodic table here. You need the periodic table of elements here. You need that. You need the periodic table to convert that, because that's where you get the molecular weight of nitrogen, which is 28 grams per mole. Then to get from the moles of N2 to the moles of NH3, you need an equation. I'm just going to say that this is an equation. You need a balanced chemical equation to do that. That's this. And to go back from grams of ammonia to moles of ammonia to grams of ammonia, you need to do the same thing with the periodic table instead. So you just take this and I'm not going to be able to copy this. The things you need to get from here to here, you need the periodic table. From here to here, you need the equation. Here to here, you need the periodic table. So let's go ahead and do it and just follow this path along with the logic that I create for you here. Let's start with what we're given, and let's say we're given in this case, we don't have to say we're given 4 significant figures. It's exactly right. Let's say we have 5,600 grams of nitrogen, and we are going to convert that from grams of nitrogen to moles of nitrogen, and then we're going to go from moles of nitrogen to moles of ammonia, and then we're going to go from moles of our ammonia to grams of ammonia. This is the skeleton we're going to populate, and this cancels this, that cancels that, that cancels that, and we end up with what we want, which is grams of ammonia. So let's populate it. So blue, first thing we find is that for nitrogen, what is the molecular weight? It's going to be 28 grams per mole. How do you know? You look on the periodic table. So let's find one. It's right here. You can look here and say twice times this number because it's 2 n's, this number right here, which is the 14.007, or you can go to molecular weight calculator. There's one here at lentech.com. They're all over the place. My calculator has one in it. You just have to go N2, you hit calculate, gives you the number right there, 28.01. So we're going to go ahead and put that in here. So how do we know what goes on the top and the bottom? Well, the units are 28 grams per mole, so we're putting in 28.01 grams on the bottom and 1 mole on the top. Switching to purple, we go from moles of nitrogen to moles of ammonia. So we get that from the stoichiometric coefficients. There's 1 here, 1 there, and there's a 2 here. So it's a 2-to-1 ratio. So we write that here. And then we go from grams of NH3 to moles of NH3. I'll save you a step of doing, well, no, I'll show you. We know what it is, but it's not for me to say what you know how to do. So I'm going to say NH3 is going to be 17.03 grams per mole. So we just go back here and write that in. And we will go blue. We'll say this time the grams are on the top because it's grams per mole. And then this is the math we have to do. We need to go 5,600 times 1 times 2 times 17 divided by 28. Sorry that should read 28 a little more clearly. Would be nice. 28 times 1 times 1. And that's going to equal whatever our answer is. So how do we do this in our calculator? So let's pull up the old calculator here. And oops, sorry, wrong thing. We will clear the screen. We go clear. We're going to exit. And here we go. 56 times 1 times 2 times 17. We're just going to 5,600. 5,600. And I'll tell you what, I'll put it in parentheses so that it looks a little cleaner. Left parenthesis, 5,600 times 1 times 2 times 17, right parenthesis, divided by, and 28 times 1 times 1. Now, I realize fully I can leave the ones out, but not everybody does. So we'll leave them in for the sake of propriety. And then we'll say, okay, 6,800 grams is our answer. So it's 6,800 grams of ammonia. So we'll put in 6,800 grams of ammonia. So does that seem a little weird to you to write this way? If it does, that's okay. You can also write it as a fraction. There's all kinds of other ways to enter the same and get the same number out of your calculator. You could have just, gone with, you could have gone with 5,600 times, and then you could have done each individual fraction. So you could have gone 1 over 28. You could have gone 1 divided by 28, right parenthesis, times, and then you could have done 2 over 2, and then 17 times 2 times 17, and it should have given you the same answer. You can also do 5,600 times 2 times 17 divided by 28. It should also give you the same exact answer. You see, it doesn't really matter, whatever makes sense to you, because of the multiplicative, the property of division and multiplication, that the order doesn't make a difference. So that's it. That's how you do that particular problem. I hope it helps out. Let me know if you want me to do one more. I have a lot more examples, but I'm trying to keep these short.